Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. The link is in the show notes. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you so much for joining me. On the show this week, I am taking a listener request, and if you ever want to make a request, shoot me an email. You can find that in the show notes, or shoot me a message on Facebook Messenger. Those are the two easiest ways to get a hold of me. And let me know what you'd like to hear about. If it's a specific topic, I can attempt to cover it myself like I'm going to today, or I can seek out someone who knows more about the topic than myself. Or if you'd like to hear from a specific guest, I'll make all the attempts I can to get said person on. That doesn't always work, but I'll try at least. Or if you'd like to be on the podcast, talk about something, hey, I'm all ears. Let me know if you're passionate in this industry. I want to hear from you and share it with all the listeners. So anyways, today is a listener request. Someone shot me a message and wanted to hear about fuel quality testing. And so it's a good topic. It's something where when I was a tech in the field, I didn't do very often. Obviously I knew we got to have quality gasoline in a vehicle for it to run correctly. And maybe I should pause there just to note the majority of the stuff I'm going to be talking about today is gasoline. We'll mention diesel, but I don't do a ton of diesel work. And so the only quality testing that I'll do involving diesel will be, is there diesel in the gasoline or in place of the gasoline or not? As far as the actual quality of the diesel fuel itself, I've never done any of that. I don't have any experience, so someone out there who lives in the diesel world probably knows quite a bit more about that than I do. But anyways, what we're going to be talking about today is gasoline. And that's what I worked on for the majority of my career and still do. And when I was a tech, I just never really looked into it too often. I was aware of the water test that you could perform to see if E85 had been put in place of, regular, in Minnesota, it's 10% ethanol is regular pump gas, has been for most of my career. You can get non-oxy, which doesn't have any of the ethanol. But I think I did that test maybe a handful of times as a tech, and I never really thought of, hey, I need to check the quality of the fuel if this particular vehicle is running poorly. Again, a couple times I did the E85 test when we had a lean condition, but it just wasn't top of mind. And the couple times where I ran into it, where the problem actually was contaminated fuel for one reason or another, it was like the last thing that I checked. I had really gone through everything else and nothing else is coming up with, a failed result. Everything is testing fine. Okay, well, I guess we have to check the fuel. And I don't know why it was last on my list. Probably because it just wasn't that common of a thing to see, but I never really thought about it. There was a couple times where the customer would come in and just tell you, like, hey, I know that I put something wrong in my tank, right? I put diesel in my fuel tank, or someone, I'm suspecting someone sabotaged me and put X in my fuel tank. Can you guys pump this out or check this out? And that's easy enough to do. That's just labor. We're not doing any diagnostic there. But to approach a vehicle that's not working correctly, maybe it's not starting at all, and determine that the fuel is the problem, it just wasn't top of mind. Now, fast forward to today. I've been doing this mobile diagnostic thing for a while. Maybe it is because it's a little bit of, I wouldn't even say harder to find, because it's not hard to check for, but it's less common to check for in the average technician world. And so it stumps a lot of technicians. And so I end up seeing more of it. At least I think that's why I see more of it. But nowadays I definitely do. And it's definitely top of mind for me as I'm diagnosing vehicles. And just about any time that I'm hooking up to a vehicle with a fuel pressure gauge, which isn't all the time, right? Because we have a lot of cars with fuel pressure sensors built into them, low and high sides, right? If it's a GDI, you've got a fuel pressure sensor of some sort. You're going to be able to measure rail pressure and probably the low side. So why would I hook up a gauge to that vehicle? Well, I might get to the point where I'm like, I need to check, fuel quality. But anytime I hook up a pressure gauge, mechanical pressure gauge to a fuel system, nowadays I'm checking the quality. Number one, because it's super easy to do, but like I mentioned, it's often overlooked, and just, confirming to myself that, hey, the fuel is not the problem. The fuel quality is good, is the right type of fuel in here. It eliminates that, and I don't have to think about that going forward in my diagnosis. Now, of course, I'm going to also take in the symptoms of what's going on with the engine or not going on with the engine, and that'll lead me to whether I'm going to check fuel quality or not. But it can cause a whole host of problems, like I'm going to go over with you here today. Now, how do we test the fuel? And this is kind of what the message was about. And I'll be honest, my testing of the fuel is relatively low tech. I did a little bit of research before this episode, just to look at the different ways of fuel testing. And there are some methods out there where you can get real scientific about it. And I think the most common one that I don't use, to be totally honest, is the specific gravity of the fuel. And what I think this is going to be most helpful for in the field, right? We're not making gasoline in a factory or laboratory or anything like that. We're just testing to see, hey, can the car run on this? Where this is going to be most useful is differentiating if it is gasoline, diesel, or a mixture. They're going to have different specific gravities. And when I say specific gravity, it's the density or viscosity. I think density is the better way to put it, in relationship to water. And gasoline and diesel are both lighter, meaning that I'll talk about this as testing, if you put them in water, they'll be on the top. They'll float on the top of water. It's like 0.6 to 7 or 0.6 to 8 for gas, and then a little bit higher for diesel. Diesel's a little denser, a little heavier. And so you could do a test. And there's some different stuff out there for this. There's hydrometers. There's also the refractometer, although I've never tried this with a refractometer. I know it has a specific gravity gauge on it, but I've never put gasoline on the little lens of the refractometer. And I'll be totally honest, I'm not 100% sure if that's safe to do for the plastic. So if someone out there has done that test or does that test on a regular basis, let me know. Be curious to know. But anyways, that is something that you can check for to see, is this gasoline? Is it diesel? Is it a mixture? And that might be one way to get you there. But as mentioned, my testing is kind of low tech, and it's got me the answers that I needed pretty much all the time. I've never been to a point where I'm like, boy, I need to, specific gravity test this fuel. I'm not saying that it couldn't happen, right? If it was a mixture of gasoline and diesel, there's a possibility that you might need to get real specific about the testing. But the testing that I use for fuel is, number one, I'm going to give it a visual. And I use a glass graduated cylinder to put the gasoline into. And my gauge has a drain, basically, where I can press a button and it will take the fuel from the system, as long as it's pressurized, into a tube and then into this graduated cylinder, which I can see, and you can measure too, but you can see the gasoline and see the quality of it. Right, and if you've seen gasoline, it has that kind of yellow tint to it. You should be able to see through it. It should look really clean. There shouldn't be any debris floating in it. It shouldn't be cloudy. You should be able to look through this. Now there's some distortion because it's a liquid, but it should be fairly transparent. And that's my first check, is like, does it look like gasoline? And I've seen a lot of gasoline. Okay. The other test is going to be, does it smell like gasoline? Now, again, I've worked with gas a lot. I'm sure all of you have, working on vehicles. You're going to be exposed to the smell of gasoline. Even if you aren't, you've been to a gas station before. Does it smell like gas? And that's a real good clue as to, is it gas, but also the quality of the gas. Now, I'm sure a lot of us in this industry as well have smelled really old gas that has like almost like a varnishy smell to it. And that's difficult to describe until you've smelled it. You're like, oh yeah, this is like really old gas. It's been sitting for a really long time. And that can happen. Cars sit for a really long time. And the quality of the gasoline can deteriorate to a point where it's not really usable, or it can cause issues like sticking injectors and things like that. So I'll give it a smell test and see, does it smell like gasoline should smell? And I can't explain that any more than that over the podcast. It's just a matter of experience there, of like, yep, this smells like gasoline, it looks like gasoline, or it doesn't. The other thing that I'll do, and this is up to you whether you want to handle gasoline. You're not supposed to get it on your skin. So for safety reasons, just putting that out there, they tell you don't get gasoline on your skin. Usually when I'm hooking up the gauge and I don't use gloves, hey, if you do, you probably should in this industry. There's a lot of chemicals that can be absorbed through your skin. It's not good for you. But I don't use gloves, and I'll usually get a little bit of gas on my fingers just from hooking up my gauge. And what I'll do is I'll put it between my index finger and my thumb. And gasoline, if it is just regular gasoline, number one, it's going to evaporate pretty quickly. It's not going to stay on your fingers for very long, especially if it's warm out. But it has a feeling to it. The viscosity or the thickness of the gasoline has a specific feeling to it. And why I bring this up is I've identified, before I've even looked at the gas in a graduated cylinder, I've identified that there is either water in the gas, or maybe just something that isn't supposed to be gas, or like isn't supposed to be in the gas tank. It isn't gas, just by this feel test. And you could potentially do this with gloves on too, but I do it between my two fingers, and you can tell a lot of the time, like, yeah, this is not gas. And water stands out really clearly in contrast to gasoline. Now, you don't have to do this test. You can put it into the graduated cylinder. You can look at it there. You can get the same determination. But I'm just pointing out all the things that I noticed along the way when I'm checking the quality of the gas and where these things stand out to me in my diagnosis. And honestly, like I've looked at it. The last one I did, it was what was that? A Chevy Uplander. It's like an old minivan, and they just put a motor in it, been sitting forever, wouldn't start. Well, it had water in the fuel. And I could tell as soon as I hooked up my gauge, I'm like, this is not gas, or it's not all gas. Now, I will say it did smell like gas, and that can be the deceiving thing, is you can have a tank that is mostly full of water, and even if it has a little bit of gasoline in there, it'll still smell like gas, but it won't feel like it. And it won't look like it. And you can bypass the feel test if you just want to put it into something. And hey, before I got the graduated cylinder, I used a empty Gatorade bottle or a water bottle. That works fine. You can see it. You're not going to be able to measure specifically, but you can see the gas. Put it into whatever container you want so that you can see the gasoline. And then just, again, you're going to do that visual test. Does it look like gasoline? Now, if this is mostly water, or even, there shouldn't be any water in there, right? There shouldn't be any water in your tank. And I have a few notes on that as well. But you're going to be able to see this because if you let it sit, it's going to separate between the gas and the water. And you know what water looks like. It's very clear. I found in the cases where water is in the tank, it doesn't look like water that came out of the tap. It's cloudy, but it has the same transparency, maybe not transparency. I don't want to say color because it's not a color, but it looks like water, right? And it's different than gasoline because gasoline has this yellow tint to it where the water doesn't. Even if it's a little bit cloudy, it doesn't have a yellow tint to it. And the gasoline is going to be on top of the water. Now, take a real close look at this. If you have a tank that's mostly full of water and you put it into one of these cylinders, you're just going to have a very small film at the very top that is yellow. That's the actual gas. And in ratio of the water to the gas, the gasoline amount is very small, but it separates and you can see just a film on top of the water. And that's a giveaway that like, okay, hey, this is mostly water. Of course, it's not going to start. The engine can't run on that. So a visual check is going to get you that answer. And I found it surprising, like how many vehicles I find that the tanks are full of water. Like, I don't quite understand exactly how that happens. I don't know if it's a sabotage or people are leaving the fuel cap off with a funnel on it. I've been very confused on how so much water gets into a tank. If somebody has a good explanation on how that happens, some sort of weird osmosis, I really don't know exactly how a tank would get full of water unless someone put it in there, but it happens. It definitely happens. Now, of course, you can have different amounts of water, but that's going to stand out. Now, any water that does make it into the system, maybe it's a little bit, maybe it's just moisture, it should be absorbed by the ethanol that's in the gas. Now, again, I don't know all the state laws, but Minnesota, 10%, roughly 10% of all like regular pump gas has to be ethanol, which is from corn and is subsidized by the government. And there's a whole thing behind that, but it's going to be a percentage of ethanol. And that was a problem because it wasn't always that way, but in the early 2000s, they incorporated that. And what you found was a lot of manufacturers, GM specifically, they were the standout. Their rubber components in the fuel systems were not meant to hold up to this ethanol. They would dissolve. So you would see fuel pressure regulators and fuel pumps and injectors all break down. The rubber components specifically would swell up and start leaking from the ethanol content. Now, other manufacturers made the rubber out of different materials and it didn't affect them. Nowadays, pretty much any vehicle you can put E85 into, which is roughly 85% ethanol, and you'll be fine. But back in the day, I just remember pump after pump after pump and regulator after regulator after regulator all swollen up and leaking from the ethanol content. Now, why I'm mentioning this is, we're going to test for ethanol because that's one of the tests that we want to make with fuel quality. But any water that's in there should be absorbed by the ethanol. And that's why those little bottles of red heat, like if you live in a cold weather climate, they try to sell these, like put this in and it'll get any moisture out of your fuel system so it doesn't freeze. That's BS, because if you're using regular pump gas, it already has 10% ethanol in there. And that's essentially what those things are. So those are a complete waste of money, I guess, unless you're putting non-oxy fuel in that doesn't have any ethanol, but that's usually just used for recreational vehicles, lawnmowers, boats, four-wheelers, a lot of things that use carburetors. People will get the non-oxy fuel, but not every gas station even sells that. You have to go to specialty stations for that. Now, that fact is good for us when it comes to testing, and many of us have done this too, where we're going to use water to assess the amount of ethanol that's in the gas, right? So E85 is a very common thing. As far as I know, you can buy it anywhere in the States. You can definitely buy it here. And if you put E85 into a vehicle that is not a flex fuel vehicle that cannot compensate for the added ethanol content, you will have a lean condition, right? The ethanol actually has oxygen molecules binded to it, and so it has less energy content. So what that means is if you're running on E85, your computer has to add more fuel to get the same energy output as if you were running on regular gasoline. So you get less gas mileage with E85. And anybody that's filled up knows if I fill it more often, I get less gas mileage, but it's a little bit cheaper. I haven't done the math to figure out if it's a wash or if there's an advantage one way or another, but there's less energy content. And what that means for drivability technicians is if the car's not able to compensate and increase that injector pulse width, if it's not able to identify that like, oh, hey, I've got 85% ethanol, there's not some sort of fuel composition sensor built into that vehicle, it's just going to assume that it's regular gas, which is, again, 10% ethanol, and it's going to add the injector pulse width for regular gas. But if it's 85, you're going to run lean. And this is where we come in as diagnostic technicians is, hey, this vehicle is running lean all the time under every condition. And nothing we can find seems to be an issue, right? Mass airflow sensor looks good. There's no vacuum leaks. Fuel pressure's okay. We can't find why this is running lean across the board. Test for E85 in the gas. And again, it's one of the early things that I'll do nowadays when I have a lean condition in all load ranges, right? If it's only at idle, I'm not thinking E85, but in all load ranges, I'm lean. Okay, let's make sure that this is actually pump gas. And then also look at the vehicle. Like, is the vehicle set up for flex fuel? Because if the vehicle's set up for flex fuel, you can go into the scan tool and you can see, what is it set at right now? What is the fuel composition? And then you can match it to what it actually is. But what you're going to do is take a fuel sample and you're going to add a certain amount of water to this. And there's measurements out there that you can use. But honestly, what I'll do is I'll add a little bit of water first into this graduated cylinder. I'll make a mental measurement of, I put it to the 10 millimeter mark. And then I will fill it with gasoline. I'm going to shake it up so I mix up the water with the gas. And then I observe where it separates out to. And if it's E85, it's super easy. I'm not even real specific with the measurements. If it's mostly clear and a little bit yellow, it's E85. If it's mostly yellow and a little bit clear, then it's regular pump gas. Okay. It's very, very simple and easy to identify one or the other. And then I'm done with that test. Okay. It's got pump gas in there. I say pump gas, they all come from the pump. But when I say pump gas, just regular 87 octane, 10% ethanol gas, or it has E85. Now, a small caveat to this, and this has only happened to me one time, but you should be aware of it, and it's a reason to actually pay attention to the measurements in that graduated cylinder. I know I just said I don't usually pay attention, but you should, and here's why. I had a 2009 Kia Sportage that would be lean under load. And we really got beat up by this one. The shop did, I did. We went after some O2 sensors. We went after mass airflow sensors. We were considering aftermarket parts were a problem. We really couldn't figure this thing out. It was only lean under a load. And fuel pressure was fine. And really everything we found was fine. After a few sensor replacements, it was very strange. And the reason I never went after fuel quality on this one, but this is part of the reason why I check it more often is cars like this. But the reason I never went after it is E85 is lean all the time. If you're in a non-flex fuel vehicle, which this one wasn't, it's going to be lean across the board because no matter where you're at in the fuel table, the engine computer is not adding the adequate amount of fuel. Because again, the E85 requires more fuel to get the same energy output. And if the engine computer is not aware of that, you're going to be lean at idle, you're going to be lean in mid-range, you're going to be lean under load as well. It's just not going to add the correct amount of fuel at any point. But this one was only lean under a load, accelerating. So you had to go drive it. You couldn't duplicate it at the shop. And again, after lots of screwing around, I finally checked the fuel quality. I'm like, well, I haven't done this yet. Let's see what this is. Well, it turned out this was actually E30, which is available at some gas stations. Yeah, right. You can get the regular pump gas, about 10% ethanol, depending on the season, or you can get the 85. You can also get E30, which is roughly 30% ethanol content. And this vehicle is not a flex fuel vehicle, and that E30 made it so this thing was only lean under a load, and it was fine at idle. Very, very strange. I've only run into that once, but it proves the point of like, yeah, we need to check the fuel quality. just to make sure that, hey, we know for sure this has got quality gas in it. And I thought that one was pretty interesting, and I couldn't remember if I'd share that on the podcast before or not. But that one beat me up for sure. And when I finally found them, I'm like, oh, okay, let's get some regular gas in here. We did it. We drove it. It was fine. All of our problems were gone. But yeah, so anyways, that's ethanol testing. Again, there's some stuff you can do with the scan tool as far as the percentage. If it is a flex fuel vehicle, that percentage can be out of whack and cause a lot of weird lean and rich and even hard start conditions. But on that note, the E85 can actually cause some no start conditions. Now, if it's really cold out, and they do change the fuel mixture, it's not quite 85% in the wintertime around here. They go more towards gas because it's harder to start a vehicle on E85 in the wintertime, especially in like January, February, where it's 30, 40 below around here. It is more difficult to start it on E85. And I used to do work for the post office way back in the day, and all of their vehicles, the government said you have to put E85 in them. They were flex fuel Ford Explorers. Well, if they did that and it was the dead of winter, guess what? Those things are not starting. They're parked outside, and yeah, some of them have block heaters, but they were not starting if they had E85 in them. So we had to talk to the post office and be like, hey, if it's below this temperature, if it's below 30 below at any point, you got to put pump gas in there, regular gas, and then you'll have a much better chance of your vehicle starting. And so they did, and they were fine. And so they switched depending on the time of year. But you can have that. Now, I did have an interesting one. It was a Honda CR-V. 04 Honda CR-V, which again, not a flex fuel vehicle. This one had E85 in it, and this thing would not even start, and it wasn't cold out. And that kind of beat me up a little bit on this because it was in a shop that was 70 degrees. And this thing would like kind of start every once in a while, run really poorly and stall. And then most of the time it was just a crank no start. And the shop went through everything they couldn't find anything. I got beat up on this thing for a little while because it had adequate fuel pressure and I couldn't find anything else that was missing. I was thinking timing on this thing. I was convinced it was timing. Turns out it wasn't. It was E85 and it was full. The customer just filled up with this. That's what was preventing this thing from starting. So they drained the tank, put regular gas in it, had to clear it out. I think they did an oil change and changed out the spark plugs as well, and then it fired up and ran just fine. So you can have a vehicle that just plain won't start from E85 in the fuel tank. So definitely something to check for, and the adding water method is the easiest way to do it. Make a mark on your graduated cylinder, and then you can figure out, okay, yep, this is E85. And if you're wondering about the specific procedure, just look up a YouTube video, and there's plenty of them out there of testing for this. They give you specific measurements. It's real easy to do. And again, for E85, you can use a Gatorade bottle and get to the conclusion pretty easily. Is it more clear or more yellow? And you have your answer of what it is. And just remember, yeah, there is E30 out there too, which can cause some weird issues. This episode is brought to you by AutoRescueTools.com and Isaac Rodell. If you are looking to get into module programming, but you are not sure what kind of laptop you're going to need or how to set it up for programming, Isaac is your guy. He can set up laptops specifically to do control module programming for specific brands with partitioned hard drives and all the software that you're going to need to do this. He also sells key cutting equipment, scan tools, and other diagnostic equipment. I bought some stuff from him in the past, and the support is phenomenal. So I highly recommend checking out the website. Again, that's AutoRescueTools.com. The link will be in the show notes. The other part of the fuel check that I'll make, you can burn the fuel, right? Put it in a safe place, obviously, but you can burn it. If it's mostly water, it's not going to burn very well, or just the surface layer is going to burn. If it's mixed with diesel, or if it is diesel, it's obviously going to burn differently than gasoline. Diesel is going to burn much slower, much different. Gasoline gives you the big whoosh. It's very quick. It ignites quickly. Diesel's not quite the same. If it's not gas at all. I had a Land Rover was it a Land? Yeah, it was a Land Rover, Range Rover. Somebody had sabotaged this vehicle because whatever was in there, I don't know what it was. It wasn't water. It wasn't gas. It was some like almost like an oily substance. Someone had put that in there intentionally. Obviously, that's not going to burn. I don't do the burn test too often, but it's something you could do just to see, hey, does this burn like gasoline? But when we're looking at that gas, the other thing that we want to look for is, like I mentioned earlier, is it transparent? Does it look clean? If it is cloudy at any point, and if you right after you first mix it up with water, it might be a little cloudy, but after you leave it sit in a graduated cylinder for a period of time, if it's just regular gas, it should have a yellow tint to it, but be transparent. It should look clean. If there's cloudiness to it, if there's sediment in it, that could really indicate there's a problem. Now, note here, your gauge could have caused that. If you haven't used your gauge in a while, right, that you're hooking up to and you're getting the fuel supply from, maybe run a little bit through the gauge. I've had that where I leave it sit for a month. I haven't touched it. I hook it up and the old fuel that was in my gauge gets kind of gross. So I'll have to run a little bit through it before I test the stuff that's actually in the car. Keep that in mind. That can happen. But if you know that it's straight from the vehicle, from the tank, the pump, the line, take a look and see if you see any cloudy sediment in there. And if there is, you got to drain the tank, get it cleaned out. Of course, obviously, pump's going to be suspect. Injectors are suspect at that point. But I wanted to point out, and to kind of wrap this up, that debris or contaminated fuel can cause some weird problems. Now, obviously, there could be some running issues as far as lean conditions go or just misfires in general. But I've encountered a couple times, and this has only been twice in all the time that I've been doing this, so it's definitely not happening every day on every vehicle, but I've run into it twice where contaminated fuel has caused a single cylinder misfire. And if you want to go back all the way to episode 12, to episode about TSBs, there's a 2007 Silverado that had a number 7 cylinder misfire under partial load. You had to go drive this thing too. Partial load, only cylinder number 7, and the shop had been through everything. They had the heads off of this thing twice going through it, trying to figure out this misfire, had double, triple checked compression because they were convinced it was a compression issue. I mean, it's a 5.3, so it very well could be, right? Cams, lifters, springs, all that stuff, rings on the piston. It could have been a number of things. And of course, they did the injector, they did the coil, the wire, the spark plug. They could not figure out what was causing this. And to be honest, it took me quite a while too. But what we ended up finding, and I found it through a TSB that I actually found through IATN, but that contaminated fuel can cause a single cylinder misfire and has something to do with the way that the rail sits and the sediment or the contaminated portion of the fuel collects at the end of the rail, which just happens to be where the number 7 injector is. And again, you had to drive this thing and go under a light acceleration in order for this to happen. You couldn't duplicate it in the shop. So something about the movement of the vehicle or the torque of the engine caused this buildup on this part of the rail, and then it misfired at that point only. And we looked at the fuel, and it was very obvious that this fuel was contaminated, swapped it out, it was fine. I had this happen one other time on a Malibu, and I don't think I had this on the podcast, but this was one where when you turned to the left and accelerated, you would get a misfire on cylinder 1, right? So if you think about cylinder 1, the front of the engine where cylinder 1 is, and it's a transversely mounted 4-cylinder, is on the passenger side of the vehicle. And if you turn to the left, the sediment or whatever was contaminating the fuel would collect. And this is my best estimate of what's going on here. It's because you can't see this happening, but I know that it was happening. I would get a misfire on cylinder number 1 when you'd have the whatever was contaminating this collect on that end of the rail. It wouldn't do it the other way. If you would turn to the right, you would not get a misfire on number 4, but you would on cylinder number 1. And that was the only time you could do it, is accelerating and cornering. And we changed it was very obvious. And every time we have this, like the sediment contamination, whatever it is, whatever was put in there, whatever happened, it was very clear when we did a visual inspection of the fuel, like, hey, look at how cloudy this is. It should not look like this. And so they changed out the fuel, and it's good to go. No more misfire. That was it. So that's what I got for fuel quality testing. I know none of that was real scientific, but that gets me through. And I mean, honestly, the biggest change for me was just remembering, like, hey, just check the fuel quality. It's not hard to do in most cases, and then you can eliminate that as a possibility. It's real quick, go or no go. And in my personal opinion, there's not a whole lot of like guesswork here. You can tell if it's quality gas, the right amount of gas in reference to ethanol, or if there's any other foreign substance in there. So hopefully that answers the question to the gentleman that requested fuel quality testing. If you got anything else to add, or maybe you have a different way of testing fuel quality, definitely let me know. But other than that, let's get out there, start fixing the world one car at a time.